Okay. Hashing. Now, for search a data efficiently, we may apply hashing technique. Now, first of all, you have to store the data and then we can search the data. We can see here there is a concept that is called bit vector representation. In bit vector representation, easily we can implement efficient searching technique. Now, suppose you have data say 3, 7, and 8. Okay. Now, if 3 is there, then put 1. If 7 is there, then put 1. If 8 is there, put 1. Now, this is what storing the data. Now, suppose we want to search. Initially, assume all are negative value. Some negative value just implement, and you know that it will never store negative value. Any negative value, it will always store the positive value. If you assume, okay, if you assume that the array always store the. Okay, now you can check whether 3 is there or not. You just see the array index. Okay, so if it is 1, that means 3 is there. Now suppose we want to check whether 7 is there or not. So we can check directly. If it is 1, then the data is there, and so on. Now whether check whether 2 is there or not. So key value is equal to say 2. So you can see here it is -1, that means 2 is not present. So without comparing with data, easily we can check whether the data is present or not. Now, two problems are there. The problems are, suppose we want to store the data 19. Okay. Now, it is not possible to store data 19 because the array index is up to 8. So we have to increase this particular array. So the question is how dynamically it is not possible to increase the array size. Okay, up to say 19, it is not possible. Okay, now first problem. Second problem is what? Suppose we have stored fewer data, say 378. So only 378 and say 19. The remaining are what? Remaining are -1. So remaining are -1 means what? It is wastage of memory space. Unnecessary, you are allocating the memory space to store the data, because we don't know how many keys are there, we don't know the range of the keys. So we may apply hashing technique. Suppose one array is there, okay, say 0, 1, 2, 3, 4, 5, 6, 7, 8. Now if you 396, 494, 535, okay, 638. Now these are the key values. Now if you use modulo 10 for all, the output are 6, 4, 5 and 8. These are called the addresses. Now 6 means you just see this particular 6 here and store the data 396. 494, so 4, you just see this particular 4, here you store 494. 535, so 5 here, so store 535. Then 638, so 638 is 8, modulo 10 is 8, so in 8 we store 638. Now we want to check whether 494 is there or not. So this is storing the data. So next is searching the data whether 494 is there or not. So 494 modulo 10, the answer is what? 4. You just check this one and compare with data 494, 490. It is matched mean the data is present. Now we want to check it is a 920 is there or not. So 920 is your 0. You just check here. So assume all are initialized with -1. Okay. So it is -1. -1 means what? The data is not present. Okay. So this is the key. These are the addresses. This is called the hash table. and this is nothing but our hash function. This is nothing but our hash function. Okay, now one problem is there. Suppose 654 is there. Now 654 modulo 10, it is 4. The question is how you can 4, but already the data is there 494. So how can you store 654 here? So this particular concept is called hash collision. Okay, so this particular problem is called hash collision. So we have to apply some techniques to solve these problems. The techniques are called collision resolutions. Okay, now this is the hash function, hash programming. So this is a program to store a hash to store a data into the hash table. Okay, here the hash function is the modulo 10. So here the array size we have used 10. So to understand the problem properly, we have used the hashing value 10. Instead of 10, we have to use any prime numbers 11, 13 and so on. Okay, now it's a search function where to search a data. Here we have used same hash function. We have to use the same hash function. Now this is the function to delete a data from the hash table. Okay, now if the data is deleted, we have to insert -2. Okay, so if it is -1, that means if it is, you can see here, if the content of the array is -1 or -2, then we can insert, it is empty. Okay, then this is the function to print. This is the function to print the content of the array, and inside main function we call the different function. So in this particular main function, press 1 to store the data into the hash table, 2 to search the data, 3 to display content of the hash table, 4 to delete data, 0 to exit. Okay, and case 1 call store function, case 2 call the search function, case 3 call the print function, case 4 call the delete function. Okay, and 0 to exit. Now we can run 1 to store the data into the hash table. Suppose you want to store data 43. Okay, now you can see here 43 modulo 10 is 3, so it is stored in the fourth index. Okay, so array index 3. Now we want to insert another data, say 657. Okay, so 657 modulo 10 is 7, so 657 in the 8th index. Okay, and the array index is 7. Now we want to insert, say, 53. Okay, suppose you want to insert 53. Now it should be hash collision. So increment the key value and insert. So it is in 50 in a fourth index. Okay, array index 4. Now suppose you want to insert, say, 83. Okay, so 83 in first time it is collision. So 43 is there. Increment. Now the index will be the 4. 53 already there. Now increment, now it is 5. Earlier it was open, it is vacant. Now we can store 83 here. Now we have to search whether 53 is there or not. 2 to search. Now we want to search 53 is there or not. 53, yeah, data found, 53 is there. Suppose you want to search 43 is there or not. Yeah, data found, 43 is there. We want to search whether 83 is there or not. Yeah, data found. We want to search whether 93 is there or not. Okay, so data not found, 93 is not there. Now 3 to display the content of the array. Now 4 to delete. Now suppose you want to delete 53. Now if you enter the data to delete 53, now you can see here 53 is not part of the array. Now we have to search whether 53 is there or not. Suppose 53 is there or not. Data not found. 53 is not there. Now you want to search whether 83 is there or not. Yeah, data found, 83 is there. Now suppose you want to search whether 93 is there or not. Yeah, and data not found. Okay,
and 0 to exit.
uh, Different hash functions are there. Okay. Subtraction, selection, folding, rotation, modulo division, pseudo random. So already you know the modulo division, so we have discussed about that modulo division. So instead of taking, the question is why should you take 10 here, value 10 value. Actually here we have to use the prime number. Okay, instead of storing 10 or less, so 11 we may use, so that number of it is seen that if you use prime number of collisions will be less. Okay. And okay, so modular division. Now suppose if the value says 0 0 0 0 or 29, so the array size is say 0 0 to 99, so we may use modulo say 91, modulo say 101, okay, 101, 103. Now subtraction, suppose uh, say few keys are there, say keys values are 6003, 6004, 6006, 6009. Okay, so these are the key. Now if you apply hash function like minus 6000 subtraction, then output are 3, 4, 6, 9. This is address, these are the addresses. Now we can use 3, 4, 6, 9 for storing the data. So 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So for 3 you just here, for 4, for 6, for 9. Okay, so here you can store 6003, here you can store 6004, here you can store 6006, here store 6009. Okay, now if the key values are like this, always like this, then we can use minus 6000. If 9003 is there, then we cannot apply 6000. Okay, so it depends upon the situation. Now selection, suppose the key values are say 4 3 2 1. Okay, then sorry, okay, so 1 5 3 2 1, say 1 7 4 2 6, 1 2 3 1 4, and so on. Now randomly we may select first this digit and this digits, okay, or this one and this one. So first and third, the output will be 1 and 3, this one and this one, 1 and 4, this one and this one, 1 and 3. Here collision is there. Now question is why should we select 2 digit? Okay, it depends upon the memory size. Your hash price, it is up to 0000 to 99 or not, or there. If it is up to 0 from 00 to 99, then we can select 2. If it is from 0 to 9, then you have to select single digit. Question is why should you select this one and this one? So randomly you can select, we may select this one and this one also. Okay, these two also you can select. Okay, but our aim is to whatever we select, the number of collisions should be lesser. Next we can see the folding method. Suppose 21, 12, 22, 12, 36. Now you just add these two digits, say 11 plus 21, 12 plus 22, 12 plus 36. So it is 32, it is 34, it is 48. So folding method, these are the keys, these are keys. Hash function is what? Addition of these two digits and these two digits, and these are the addresses, key address, okay, in array index. Folding method. Now rotation method we can check. Suppose 5006, 3006, 9006, 8006. Now suppose your key values are like this, then what you can do, we can apply rotate left. So if you apply rotate left, the output will be what? 0065 0063, okay, then 0069 0068, and if you select last two digits, the output will be 65 63 69 and 68. These are the array index. These are nothing but array index, or these are nothing but the addresses. So this is called the rotation method. Modulo division already you know. Now pseudo random. So key values are there, and we have to apply the formula y is equal to a key plus b, where a and b are the constant. These are constant small prime values. We use small prime values. Let a is equal to say 3 and b is equal to 1. So if it is the case, suppose the key values are 33, 41, 82. Then the address will be y is equal to a is what? 3 into 33 plus 1. So 99 plus 1, it is 100. Next time it is 3 into 41 plus 1. So it is 124. And here 3 into 82 plus 1. So it is 127. Okay, sorry, 24, 247. So it will be 247. Okay, so these are 100. So key values are 33. Y is equal to a key into b. What is a? A is equal to, assume 3. B is equal to 1. What is key values? These are the key values. So a into key plus 1. So 100. These are nothing but the addresses. Address means the array index. So 100, say somewhere it is 100. So we can store something. 124. So it is 124. So where we can store this one. 82. So if it is 247, you can store 82 here. Okay, this was what? Pseudo random. Now these are the hash techniques, hashing function, hashing techniques. Some more techniques are also there, and we can use combination of hash functions. Say we can use these two at a time, we can use these two together, okay, we can use these three together. Now collision resolution. Suppose 34 modulo 10, 54 modulo 10, 94 modulo 10, 64 modulo 10. So all are the 4. These are the keys. Hash function is modulo 10 and address is equal to 4. 0, 1, 2, 3, 4, 5, 6, 7, 8. So 3410, so we can store here. Next time 54 modulo 10. Now it is 4. Now it is collision is there. So what we can do, we just increment this 4 value. So whatever the key address is there, plus 1. So 4 plus 1, 5. So here we can store 54. Now 94, 4 is there. So check, it will check this one. So 34 is there, it is occupied. Now increment, so 4 plus 1, 5, it is also occupied. Then 5 plus 1, 6. Now it is vacant. Here we can store 94. Now suppose you want to check whether 34 is there. Now this is what? Storing the data. So for storing the data and for searching the data, we have to apply same hash function. Now this one is what? Storing the data using hash function. Now searching the function whether 34 is there or not. So 34 modulo 10, 4, you just check 4 and compare these two. Match, it is matched and data found. You want to check whether 94 is there or not. So 94 modulo 10, it is 4. Compare 94 with this content. Okay, it is not matched. Increment the address value. So 4 plus 1, 5. Compare 94 and 54, it is not matched. Increment. Now it is 6. 94 and 94, it is matched. Data found. You want to check whether 74 is there or not. So 74 modulo version is what? 34. Condition, it is not match, increment, not match, increment, not match, increment, data not present. So data not present means what? 74 is not present. Okay. Now another technique is there. Suppose the values are say 4, 54, 90, 0, 1, 2, 3, 4, 5, 6, 7. Now 34 we can store here. Now 54. So first plus 1 add, then subtract 1, then plus 2, then subtract 2, then plus 3, then subtract 3, and so on. So first time 4 plus 4, 4 plus 1 it is 5, so we can store 54 here. Next time 94, so 4 minus 1, 4 minus 1 it is 3. So here you store 94 here. Next 84, 4, so 4 plus 2 it is 6, so here we store 84 here. Then say 74 is there, then 4 minus 2 it is 2, so here we store 74. Okay, so all the data resides around this particular key value. So around this particular key value all the data present. So it creates a group. Now another technique is there. Suppose pseudo-random technique, you can see here. Suppose the data are 34. So we may apply pseudo-random. So a into address plus b. Assume a is equal to 3. Assume a is equal to 1. B is equal to 3. Okay. So here modulo 10 4 4 4 4. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. It is 4. Then it is here you can store 34. Then 4 collision is there, so we have to identify the y value. So e is what? 1 into 4 plus b, that is 3. So 4 plus 3 it is 7. So here we store 64 here. Next, so this is 4. Then next 94 into 10. So first time it is collision, apply the hash function, the output is 7. Next time it is 1 into 7 plus 3, that is 10. So this one you can store here 94. So if collision is there, recalculate the address and according to y store the data. Okay, this is pseudo-random generation. Now quickly you can view the linked list approach. So 0, 1, 2, 3, 4, 5. We can use linked list to store data. Say few data already present in this particular. Now suppose 94. Okay. Now if it is 94, 10 it is 94. So in 4 we store 94. Next 64 is there. Okay. Modulo 10 it is 4. So just create one node and store 64. Now 34 is there. Sorry. 34 is there. It is 4. Okay. So we store 34 here. It's a linked list approach. And bucket approach is also there. See. So second index starting with second, third, fourth. Say 93 is there, then it is 3, 63 is there, and 53 is there. So 93 it is 3, so here you can store 93, then 63 modulo 10 3, then you can store 63 here, 53 modulo 10 is 3, so you can store here. Now 43 will appear, then 43 modulo 10 it is 3, then it is already it is occupied by all the data. Now increment, so 3 plus 1 4, now store 43 here.